So in this lecture, we are going to start a new method, that is the power method. This method is an iterative technique which is used to determine the dominant eigenvalue and its corresponding eigenvector. So what does actually dominant mean? Dominant means to determine the dominant eigenvalue and vector. So here dominant means the largest eigenvalue in magnitude. So the power method tells the largest value, that means the largest eigenvalue with the in magnitude. So what So when we have only 3 cross 3 system, then we can easily determine that what will be my eigenvalues. But suppose sometimes we have 100 cross 100 matrix, and solving 100 cross 100 matrix is not so easy when you only want one eigenvalue which will be the largest. So in that case, this power method is successful. So what is the procedure to find it? So we will write here the procedure to find the dominant eigenvalue and eigenvector. So the first step is that you can start with any, because it is an this is an iterative technique. So if you remember, we always start with an initial approximation. So we can start with the initial approximation. Start initial approximation of dominant eigenvector. Suppose we are naming that, say this is your x0, and we choose this the initial vector so that the vector's norm should come out to be max norm should be 1. So you can choose any vector 1 0 0 and so on, 0 1 0 and 1 1 1 1, so that the max norms come out to be 1. So what is the process? Because it is an iterative technique, so in the first iteration we will multiply our A matrix, which will be given to us for whom we have to find the eigenvalues and eigenvectors. So you can multiply the initial approximation with this vector A. So when you will multiply, you will get a vector this, that will be your y vector. So how you can take that is your x vector. So you can take the highest value common from this, right? So that will be nothing. When you take the highest value out, that will be nothing, that will be your norm. So you can write your x1 will be nothing, but when you divide your y1 vector with its norm, so when you take out the norm out, so the resultant vector will become your x1. Either you can choose this way or you can choose this way. So this vector with this norm which will come out, this will be nothing, that is the first approximation of your eigenvalue. The norm will denote the eigenvalue and the resultant vector will be your eigenvector. So continuing in this way, what you have to do in the next step, you will multiply that is your second approximation, you will multiply your A matrix with this vector which you have obtained x1. In the same way, you will get one more vector over here. So what you can do, you can take out the norm and there will be the resultant vector. So this vector will be nothing, that means the second approximation of your eigenvector, and this is nothing, this is your second initial, that is the second iteration for your eigenvalues. Continuing this way, that means if we have to perform n iterations, so what we will have axn, so that will be my resultant vector. I'll take out the norm outside, so that means that will be your nth iteration for your eigenvalue and vector. So this will denote your nth iteration of the eigenvalue, and this will denote your vector, that will be your eigenvector, right? Continuing this way, like we have already done. So what can be the stopping criteria? Stopping criteria can be anything which will be given to you. Either it can be based on your eigenvector, or it can be based on your eigenvalue. So stopping criteria can be like this, that lambda k plus 1 minus lambda k should be less than or equal to your tolerance, right? Or it can be your eigenvector, that xk plus 1 vector minus xk vector, that means the norm should be less than equal to the tolerance. Or you can say for your relative error, that xk plus 1 minus xk, or on this place it can be xk plus 1, right? So norm. So stopping criteria can be anything. So we will discuss example from it. It will be clear. So if you have example, the matrix is given to you A, that is your 8 minus 6 2, right? Minus 6 7 minus 4 2 minus 4 3. You have to calculate eigenvalue and eigenvector of A, and the stopping criteria is that you have to perform only 5 iterations. So you have to perform 5 iterations. So the benefit of actually your, you have to calculate it by power method. So the benefit of power method is that it gives you the eigenvalue and your eigenvector simultaneously. And the other method gives you eigenvalue only. So this is the benefit, that it gives you eigenvector and your eigenvalue simultaneously. So what is the process? Because we have to use the power method, so we have to start with the initial approximation. We can start with any initial approximation, so that my norms became 1. So I can use, this is your 3 cross 3 matrix. So I can take the vector, that will be your 3 cross 1. So this is your x. So what was the process? That we have to calculate y1. That means we will multiply the matrix A with this eigenvector. So that means I have to multiply 8 minus 6 2 minus 6 7 minus 4 2 minus 4 3 with your eigenvector. The eigenvector here is your 1 1 1. When you will do the multiplication, the answer will come out to be your 4 minus 3 1. So what I have told you, that either you can divide that your x1 vector will be your y1 vector divided it by norm, and norm will be your eigenvalue. So otherwise you can take, because the largest value in magnitude, if you take out the norm, that will be your 4. So when you will take out 4 common, so 4 divided by 4, that will be 1, minus 3 by 4, that will be minus 3 by 4, that will be equal to your minus 0.75, and this will be your 1 by 4, that will be your 0.25. So this is the first iteration for your eigenvalue, and this has become your eigenvector. So in the next iteration, what you have to do, y2, how you will find y2? That multiply your A matrix with your vector x1. So that will be your A matrix is this, the same matrix which is given to you. Don't multiply this vector here. This will be wrong. You have to take this x1 vector here. So here it will be your 1 minus 0.75, only the vector, not the eigenvalue, 0.25. So when you will do multiplication, you will get the answer that will be your 13 minus 12.25, 5.75. Now, how you will find the eigenvector from this? You can take the maximum element out from this, so that will be your 13. So the rest you can divide 13 by 13, that will be 1. And when you will divide this will be your 0.94231. This will be your 0.44231. Now this is nothing, but this is your second approximation, second iteration. That means your for your eigenvalue, and this is your second iteration of your eigenvector. The same, and you will perform your third iteration. Third iteration, what you will do, you will multiply your matrix A with your vector x2. That means the matrix A which is given to you, and your vector this one minus 0.943231, 0.44231, and when you will multiply, it will result into that it is 14.53846 minus 14.36538 and 7.09615. So what you have to do next, you have to take the maximum element common, so that will be your 14.53846. So when you will divide, the result will be minus 0.9881. This is 0.4881. So next iteration you will perform that. The y4, that will be your a into your x3. And what is your x3? This is your lambda 3 and this is your x3. So when you will multiply, this will give you answer. That will be your 14.90476 minus 14.86905 and the 7.41667. When you will take maximum element out, so this is 14.90476 and this will result into 1, 0.9976. This will be 0.4976. So when you have to perform the next iteration, because the question is given to you that you have to perform 5 iterations. So y5, that means a into x4. So what is your x4? This is your x4 and this is your lambda 4. So when you will do multiplication, so you will have 14.98083 minus 14.7364 and this is your 7.48323. So when you will take the maximum element out, so that will be 14.98083 and when you will divide, this will be 10. This is 99952 and this is your 0.49952. So since you have to perform only 5 iterations, so stopping criteria is only 5 iterations. So at fifth iteration, you got the dominant eigenvalue. That means the largest eigenvalue in magnitude. That is the dominant eigenvalue is your 14.98083. That means this value, that is your fifth iteration, and this is your dominant eigenvalue. So the dominant eigenvector will be your this 1 minus 0.99952, 0.49952 transpose, right? So this is 3 cross 3 matrix. So you can determine other values also if it is one of the value eigenvalue. So how you can determine? You can use, the sum of the eigenvalue that will be equal to your trace of the matrix and the product of the matrices, or the product of the eigenvalues that will be equal to your determinant of A. So since you know your lambda 1, right, you can use this property. Trace A is nothing but the sum of your diagonal elements and determinant you can find. So from this process, you can find also the other eigenvalues as well, right? So the question can will be based on this. The stopping criteria only will be different. So the next, you can write out, you can write some remarks. So when we are doing the power method, we are assuming here that the matrix A is, which is your n cross, will be your n cross n matrix, has n eigenvalues lambda 1, lambda 2, and lambda n with an associated eigenvector with an associated eigenvectors v1, v2. So we are assuming कि आपकी मैट्रिक्स जो है n क्रॉस n की होगी, तभी आप आइगन वैल्यूज निकालते हो कि आपकी n आइगन वैल्यूज उसकी आ रही हैं जिनके वेक्टर्स क्या हैं v1, v2, vn, right? Moreover, in this we are assuming, actually as the name indicates power method, so we actually calculate the powers of A. So here we assume that lambda 1 is the largest eigenvalue in magnitude. That's why this process follows. Third, suppose when A has not an linearly independent linearly independent vectors, right? Then power method may still successful, but it is not guaranteed. So what happens in this case कि अगर आपकी मैट्रिक्स है कोई जिसके आपके n linearly independent वेक्टर्स नहीं है, तब भी आपका पावर मेथड सक्सेसफुल हो सकता है, बट उसकी गारंटी नहीं है कि क्या वो कन्वर्ज करेगा भी या नहीं. It can be successful, it can be unsuccessful also. The next is, it is not necessary. It is not necessary that A has and distinct eigenvalues. कई बारी पॉसिबल होता है ना कि ए की आइगन वैल्यूज 2 2 1 ही आ गई, दैट मींस इट हैज नॉट 3 डिस्टिंक्ट आइगन वैल्यूज, 2 इज कॉमन. So it can be possible that A has and distinct. It is not necessary that A has and distinct values. So if the matrix A has unique dominant eigenvalue, lambda 1 with multiplicity R which is greater than 1, like this, if you have 3 cross 3 matrix 2 की यहाँ पे multiplicity कितनी है 2. So that means अगर आपका कोई आइगन वैल्यू है जिसकी मल्टीप्लिसिटी R है, right, and its vector v1, v2, vr are linearly independent eigenvectors associated with lambda 1, then power method will still converge टू लैम्डा 1। दैट मीन्स अगर आपकी यूनिक आइगन वैल्यू मतलब आपकी आपकी आइगन वैल्यू की मल्टीप्लिसिटी जो है वो 1 से बड़ी है, तब भी आपका पावर मेथड जो है लैम्डा 1 को कन्वर्ज करेगा। बट इन दिस द सीक्वेंस हेयर will in this case converge टू एन आइगन वेक्टर। लैम्डा 1 को तो हमारा पावर मेथड कन्वर्ज करेगा, बट आइगन वेक्टर कौन सा होगा? सो दैट मीन्स आइगन वेक्टर जो आप एक्स ले रहे हो चाहे आप पी लो, दैट मीन्स will converge to an eigenvector of lambda of जिसकी आपकी मैक्स नॉर्म आ रही होगी equal to, that will be equal to one of the choice of initial vector x naught and is a linear combination of v1 v2 vr। दैट मीन्स अगर आपकी मल्टीप्लिसिटी जो है आर से बड़ी आ रही है, तो जो आपका वेक्टर आएगा, वेक्टर कैसा आएगा? दैट विल डिपेंड ऑन योर नोम, जो आपकी जिसकी नोम आपकी 1 आ रही हो, मैक्स नोम आ रही होगी। और एंड दैट विल बी इक्वल टू, किसके इक्वल होएगा? जो आपकी इनिशियल चॉइस पे डिपेंड करेगा, बट जो हाँ वेक्टर जो आपके पास आंसर आएगा वो किसका लीनियर कॉम्बिनेशन होएगा? जो उसके एक्चुअल में आइगन वेक्टर्स आ रहे हो, right? So the last is, since power method is useful, since power method is useful to compute dominant eigenvalues, so to find other eigenvalues, I have already told you that you can use the properties of the matrix to find the other eigenvalues. We can use trace of a matrix. That trace of a matrix I have told you that will be equal to your sum of eigenvalues. And the determinant of A will be equal to your product of eigenvalues. So you can also use these properties to find the other eigenvalues also. So this is all about the power method. So the power method gives you the largest eigenvalue. The next is your inverse power method. As its name indicates, inverse, that means here we will use the inverse. So you have used the property कि a की अगर आपकी lambda आइगन वैल्यू है, that means 1 by lambda आपकी a inverse की क्या हो जाएगी? That will be the smallest value. So that actually that property will use. So this inverse power method is nothing, but it is the modification of power method. Or this method is also useful when you want to find the value, eigenvalue close to some number. So this is the modification of power method which is used to determine the eigenvalue of A that is closest to specified number q or with smaller magnitude. That means, as its name indicates, you can find the eigenvalue which is closer to some number q, right? Or you can find the eigenvalue which which will be smaller in magnitude, right? So you can just remember what you have earlier done, that if it is given to you that if lambda is an eigenvalue of a, अगर आपकी कोई मैट्रिक्स है a और जिसकी eigenvalue मेरी क्या है lambda, then these properties hold that lambda raised to the power k is an eigenvalue of a raised to the power k. That means अगर आपकी a की कोई अगर आपकी आइगन a की मैट्रिक्स a कोई मैट्रिक्स है, सपोज उसकी आइगन वैल्यूज आ रही हैं 3 2 1, तो अगर मैं कहूँ a रेस टू द पावर 100 की आप आइगन वैल्यूज निकालो, दैट विल बी नथिंग, दैट विल बी 3 रेस टू द पावर 100, 2 रेस टू द पावर 100 and 1 रेस टू द पावर 100. So this property hold that lambda k is an eigen value of a raised to the power k. The second property is that lambda inverse is an eigen value of your a inverse. For example, a की अगर आपकी मैट्रिक्स है जिसकी आइगन वैल्यूज 3 to 1 है, दैट मीन्स ए इनवर्स की आपकी आइगन वैल्यूज क्या होंगी 1/3, 1/2 and 1. Moreover, the third is that lambda minus sigma is an eigen value of a minus sigma i. अगर आपकी कोई मैट्रिक्स है ए जिसकी आपको आइगन वैल्यूज पता है, जैसे सपोज हम कह रहे हैं यही, अगर मैं यही क्वेश्चन होता कि a-2i की आइगन वैल्यूज निकालो, तो आप क्या करते, जो आपकी आइगन वैल्यूज ए की हैं, आपकी ए की आइगन वैल्यूज क्या आई हैं 3 to 1, दैट मीन्स दैट विल बी 3 - 2, 2 - 2 and 1 - 2. So this will be the eigen values of your a minus 2i. So it says lambda minus sigma is an eigenvalue of a minus sigma I. Next, we will just state one theorem. We will not do its proof, right? This theorem we will use to find the closest eigenvalue of some matrix with the specified number, right? So it says if A has eigenvalues lambda 1, lambda 2, lambda n with n linearly independent vectors, v1, v2, vn, right? Then the eigenvalues of a minus qi inverse, where your q is not equal to lambda I for I is equal to 1 to n r, that will be your 1 upon lambda 1 minus q, 1 upon lambda 2 minus q, 1 upon lambda n minus q with the same eigenvectors, that will be your v1, v2 and vn. So lambda q is not equal to lambda I. Why? Because इनवर्स की आप बात कर रहे हो, यहाँ पे आप चेक करो कि आपने जब मैंने आपको कहा था कि ए आपकी मैट्रिक्स है जिसकी आइगन वैल्यूज है 3 to 1, राइट? तब मैंने कहा कि a minus 2i की तो आपकी आइगन वैल्यूज ये होंगी, बट इनवर्स की आप क्यों नहीं कह रहे q इज नॉट इक्वल टू लैम्डा i? क्यों? क्योंकि आपका यहाँ पे 2 - 2 आपका क्या आ गया 0, और आपने कहा है कि the product of the eigen values is equal to the determinant of A. तो अगर आपकी एक आइगन वैल्यू भी जीरो आ गई, इसका मतलब आपका डिटर्मिनेंट ऑफ ए जीरो आ गया, दैट मीन्स आपका ए इनवर्स पॉसिबल नहीं है. So that's why it is saying that Q is not equal to lambda I. So the eigen values in that case will be when Q is not equal to lambda I. That means A minus Q I inverse की वैल्यूज क्या हो जाएंगी? 1 upon lambda 1 minus Q, 1 upon lambda 2 minus Q, and so on. So therefore, you can notice from here that the largest eigen value of A inverse will be the smallest eigen value of A. So that means जो आपकी A inverse की largest eigen value होगी वो आपकी smallest eigen value of A होगी. So you can notice over here कि अगर आपको smallest निकालनी है वैल्यू, पावर मेथड आपको देता क्या है? सिर्फ लार्जेस्ट आइगन वैल्यू. अगर आप पावर मेथड ए इनवर्स पे लगा दोगे तो ए इनवर्स विल गिव यू द लार्जेस्ट आइगन वैल्यू, दैट विल बी नथिंग, दैट विल बी द स्मॉलेस्ट आइगन वैल्यू. सो नाउ टू फाइंड द आइगन वैल्यूज क्लोज टू सम नंबर, so to find eigen value close to some number q, suppose we are saying close to q, correspond to the largest magnitude of the shifted and inverted of the shifted and inverted of matrix A minus QI inverse. That means आपने मैट्रिक्स को शिफ्ट कर दिया और उसका इनवर्स, दैट मीन्स द शिफ्टेड एंड इन्वर्टेड. अगर आपको आपकी आइगन वैल्यूज किसी नंबर Q के चाहिए, so you will find the largest eigen value of your A minus Q inverse. The same process will remain same that you have already done. So what will be your process over here? That firstly, to find eigen value close to sigma or close to Q, what you will apply? You will apply the process. That means, so the first step, आपको किसकी वैल्यू निकालनी है? A minus QI के. So you will apply your power method to obtain आइगन वैल्यू ऑफ, आपको किसकी वैल्यू निकालनी पड़ेगी? हम क्या कह रहे हैं, अगर सिग्मा के नजदीक चाहिए तो मुझे किसकी वैल्यू निकालनी पड़ेगी? ए माइनस सिग्मा आई इनवर्स की वैल्यू निकालनी पड़ेगी, लार्जेस्ट आइगन वैल्यू पावर मेथड से. देन वी कैन रिकवर, then we recover eigen value lambda of A, that means the original matrix which will be given to you, जिसके आपको नजदीक वैल्यू निकालनी है, by that will be lambda will be nothing but that will be 1 by mu plus sigma, because you use the property इसकी वो inverse की क्या हो जाएंगी? 1 upon mu minus sigma, so that means you will obtain your lambda value, that will be 1 mu plus sigma. So one more remark over here in this, since A minus QI inverse you have to obtain, so the question also can be given to you that without finding inverse, find the smallest eigenvalue. So you have already done that. To find the smallest eigenvalue, you have to use the inverse. That means you will find the largest eigenvalue of inverse. So, but you need not to find inverse. So, if you remember, we have already done. अब हमें प्रोसेस हमारा क्या है कि हमें y क्या निकालना है? A inverse x करना है. but you have already done a process in, if you remember, that I can write this as ay is equal to x. To find this x will be given to you. And how I can find this y? I can decompose this A matrix into my two matrices, LU decomposition y. So that will be give you your y matrix, so that you can use, right? So in that case, you are not using the inverse, you are using the LU decomposition to find the vectors, right? So we will do example, then it will be more clear. Right? So suppose the question is given to you that let A is your matrix 1, -1, 0, -2, 4, -2, 0, -1, 2. This matrix is given to you. You have to use 4-digit rounding. Remember, 4-digit rounding means that means you should have 4 significant digits after doing rounding, and the initial approximation is given to you that you have to take the initial vector as 1, 0, 0. So the further given to you is this, without calculating inverse, right? Find the smallest eigenvalue of A, and you have to perform only 2 iterations. The stopping criteria can be anything. So we have to find the smallest eigenvalue. For the smallest eigenvalues, I always need to find the inverse. So that if it is not given to you, you can directly proceed that you find the inverse, and you just proceed y is equal to a inverse x. So that will give you vector, and that you have performed in the previous. Then you will perform y1, that will be your a inverse x naught. Y2, you will take a inverse into x, one vector, and so on, right? But if it is given to you without calculating inverse, so you need not to calculate your inverse. So A matrix is given to you, the initial vector is given to you, that is your 1, 0, 0. So since we have to do this iteration, that means y will be my A inverse into x. So what we can do, this will be my A, y is equal to x. We will decompose this matrix into two matrices L, U, Y. If you remember, L we have done, that is the lower matrix. लोअर मैट्रिक्स में आपके डायगोनल एलिमेंट्स क्या हो जाते हैं 1, and rest you have like this 1, 1. The other elements here will be 0, and this will be your first multiplier, that will be your m21, this will be your m31, and this will be your m32, and u is your upper matrix which you obtain by your Gauss elimination without pivoting. So when you will do your process, your matrix LU, that will come out to be your L matrix will be come out to be, that will be your 1, 0, 0, -2, 1, 0. This is 0, minus 0, -0.5, and this will be your 1, and your U matrix come out to be your 1, -2, 0, 0, 2, -2. This is your 0, 0, 1. So if you remember the process, but we have done LU decomposition. जब हमें LU composition करनी थी, that will be equal to LU x is equal to B होता था. हम क्या कर लेते थे, UX को हम Y मान लेते थे. We solve LY equal to B. तब हम Y की वैल्यू निकाल लेते थे, और फिर इसमें हम Y की वैल्यू सब्स्टिट्यूट कर देते थे, और किसकी वैल्यू निकाल लेते थे, x की वैल्यू. So since you y and x you are already assuming over here, so what you can do, because we have to you choose ux is equal to y. So when you have decomposed lu, this is your y is equal to your x, right? So that means you can assume uy is equal to new vector you can take, because you have to do the first iteration. So uy1 vector you can take z1, right? So this will become your lz1 will be equal to your x naught vector which is given to you. So that will be your, when you will do, this will be 1 0 0 minus 2 1 0. This is 0 minus 0.51, right? You multiply, this will be your vector z1 z2 z3, right? And the vector, initial vector given to you 1 0 0. So when you will use the forward substitution, you will get the vector z1 vector. That means the vector, this will be your 1 2 1 transpose. Now since we have obtained the value of z, what we will do, we will substitute in this function. So that means, so from here, what I'll get that my uy, that will be equal to your z1. So u matrix, you know, which is given, you which you have already obtained, that is 1 minus 1 0 0 2 minus 2 0 0 1, and the vector is, this is your y1 vector, and the z vector is, you have already obtained 1 2 1. So when you will solve, you will get the y1 vector will be your 3 2 1. इफ यू रिमेम्बर द प्रोसेस, मैंने आपको क्या कहा था कि अगर आपका वेक्टर आ गया 3 2 1, दैट मीन्स दिस इज वेक्टर 3 2 1. हाउ वी ऑब्टेन द आइगन वैल्यू एंड द आइगन वेक्टर फ्रॉम दिस, that this is my 3 2 1. How I obtain, that I take the maximum value y, that will be 3 will be out, this will be 1, this will be 2 by 3, because you have to do 6-digit rounding, so it will be 66667, and this will be your 0.3333. So what actually becomes, this is your first iteration for your initial eigenvector, and this is actually, you are finding it for inverse, so you can denote it by mu, because lambda, you are saying the eigenvalue of A. So mu I am denoting, that means eigenvalue of your A inverse. So here you are calculating the basically eigenvalue of A inverse. Now you have to perform 2 iteration. For the second iteration, you will also perform in the same way, that you will take this vector uy is equal to, आप z कर दोगे, तब आप सबसे पहले क्या करोगे, that you take LZ2 vector, that will be equal to your x1. So like this you will perform LZ2 vector, आपका किसके इक्वल आ जाएगा, x1 के. So when you will perform operation, so you will get z2 will be your, come out to be your 1 2.667. This will be 1.667. So this is, you have transpose. So when you have to perform this iteration, that means uy2, that will be equal to your z2. So when you will get your y2 will come out to be your, this will be your 4 3 1.6667, 4-digit rounding. So now when you will take, this will be out, this is 4 1, this will be 0.75, this will be your 0.4167. So this is your 4167, right? So this is your lambda 2, and this is your eigen, so this is your mu, not lambda. So this is your eigen vector x2. That means you have the stopping criteria is only the 2 iterations. So mu2 you have already obtained, that is your 4. And how you will obtain the smallest eigenvalue, lambda will be nothing, that means that will be 1 upon mu2, that means the smallest eigenvalue of A, that will be your 1 by 4. So that means 0.25. So this is your smallest eigenvalue only for your 2 iteration. And obviously we have already done that theorem, that means the corresponding eigenvector will be same, which is for your A inverse. So that will be your 1 0.75 0.4167 transpose. So if it will not given to you that without calculating inverse, you can just proceed, take y is equal to A inverse x, perform the iterations, take the maximum element out, and then perform the second iteration, right? Proceed like this. You can proceed like this and you will get your answer. Next, this is for finding the smallest value. Suppose we have a question that you have to apply inverse power method to find eigenvalue of matrix. The matrix is -4, 14, 0, -5, 13, 0, and this is -1, 0, 2. Eigenvalue of matrix near number 19 by 3. So since you have to apply your inverse power method, that will be nothing. So आपको क्या करना है? You will just apply A minus, that is this your sigma. Sigma is your 19 by 3, right? Into I, that will be inverse. You will apply your inverse power method. So आप उसके बाद lambda कैसे recover करोगे? Lambda हमने क्या किया था? 1 by mu plus sigma. So you will get eigenvalues of this matrix, you denote it by mu, and that lambda will be 1 by mu plus sigma. So how you will proceed? You will proceed like y1 will be my A minus 19 by 3 I inverse, that will be my initial vector x naught, and also x naught vector is given to you, that you have to take 1 1 1, right? Transpose. So you can easily find A minus 19 by 3, that means you will just find the inverse, and when you will do the calculation, so your first vector, this is coming out to be your minus 6.6, minus 4.8, 1.292, right? So from this, because it has two negative over here, so we can take the maximum, that will be minus 6.6 out, so it will be 1. This will be your 0.7272, and this will be your minus 0.1958. Suppose इसी एक ही iteration आपको करनी होती, तो this is what? This is my mu, and this is my eigenvector. So you have obtained mu. How you will recover lambda? Lambda will be nothing, that will be 1 by mu plus sigma. So that means 1 by, that will be my minus 6.6 plus sigma, that will be 19 by 3. So when you will do 6.1818, and next you can perform your iteration like this. So you can calculate y2, that you take the A minus sigma inverse into your this vector x1, and you can proceed like this, right? So the stopping criteria, other thing also can be, I have already told you, lambda k plus 1 minus lambda k 0 point. So you just can try on this, that if your A matrix is given to you, you can do this as for your practice. So this is 0 minus 3 9, so this is 0 0 minus 0.5, right? So you have to find your apply power method, right? Apply power method and find the largest eigenvalue of A and smallest eigenvalue of A inverse, and the stopping criteria is that you have to stop lambda k plus 1 minus lambda k जब तक आपका tolerance level 0.1 से कम नहीं होता, you have to perform the iteration. So when you will start with this, now notice over here this, you have to find the largest eigenvalue of A and smallest eigenvalue of A inverse. That means this is in the relation that अगर आपने A की largest eigenvalue find कर ली lambda, so A inverse की आपकी smallest eigenvalue क्या होगी? That will be your 1 by lambda. So you need not to do the calculation again. You can just perform. So when you will solve, you perform the iteration for the first iteration. This is giving me answer as 6 as 1 minus 1 0.0833. So for satisfying this criteria, you have to perform your 5 iterations, and the 5 iteration and the answer is coming out to be your minus 3.004, and your eigenvector is coming out to be your minus 0.45802, and this is 1. This is 0.000818. So your largest eigenvalue will be minus 3.05, and mu will be the smallest eigenvalue, that will be 1 by lambda of A inverse. So one thing you can notice over here, and you can also verify that this is your lower triangular matrix. In lower triangular matrix, what are my eigenvalues? That the diagonal entries are my eigenvalues. So eigenvalue here you can notice over here that this is 1 minus 3 and 0.5. So the largest eigenvalue is minus 3 that we have obtained, right? So when you will perform other iterations, you will approach to minus 3. And the smallest eigenvalue you can find by the A inverse, and the A inverse smallest eigenvalue will be 1 minus 1 upon minus 3, right? So next, last, that you can just write remarks on this. So remarks means failure of power method, that when it fails. We have done कि अगर आपकी आइगन वैल्यूज जो है एंड आपके डिस्टिंक्ट आइगन वेक्टर्स नहीं होते, तब भी आपका पावर मेथड सक्सेसफुल हो सकता है, बट गारंटी नहीं देता. बट कब आपका पावर मेथड सक्सेसफुल नहीं होगा? व्हेन ए इज नॉट डायगोनलाइजेबल, अगर आपका ए डायगोनलाइजेबल नहीं है, right? The examples which we have done in that, A is your diagonalizable. When A does not have dominant eigen value or eigen value is such that that your lambda 1 is equal to lambda 2. That means अगर या तो आपकी dominant eigen value है ही नहीं, या ऐसे भी हो सकता है ना, ए की मैट्रिक्स जो आपकी डायगोनल आपकी एंट्रीज आ रही है वो ऐसे हो जाए 2 minus 2 1, तो दोनों ही मैग्नीट्यूड में सेम है, तब भी आपका पावर मेथड फेल हो जाता है, राइट? थर्ड इज because I have told you, as the name indicates, the power method. So if the entries of A contain, आपकी A में ही आपका significant error है, because when you do your power method, actually you are calculating the power of A. So power of AK will have more significant round of error. तब आपका बहुत ज्यादा error होगा A raised to the power K में भी, in the entry, right? Okay. So this is all about your power method, right? Thank you.